Hello, good evening, all. So today we'll be going to do week three activity and the practice questions. So maybe you can put your doubts in the chats, or you can just tell me what topics from week three you have difficulty in, and we can discuss that first and then move to the problems. Nobody has any doubts from week three. Am I audible?
Yes, ma'am.
Okay.
Yes.
Um, so do you have any doubts, or what do you want to do today?
You are going to take my doubt.
Sorry.
You are going to take my doubt, right?
Uh, what doubt? You didn't post anything, right?
I mean, I just asked about. Oh, in the last session,
Um,
I
is
asked
it
about I asked about the pareto chart.
better to chart?
Yeah.
Oh, okay, okay. Uh, right, right. Okay. Bhargav, right?
Yeah.
Yeah. Can you put your email ID in the chat, possible?
Yeah. I will put it
I
right.
will maybe mail you because Discourse, I don't think, Discourse is not active for you, right? Or discussion forum
No, no.
is where you're getting post. Okay, just give me your email ID. I will mail you there.
I sent you.
Yes, I got it. Okay. So week three, has any session happened before this, or this is the first week three session?
Ma'am, two sessions are already done.
From week three?
Yes, ma'am.
Oh, okay.
One is explanation session and one is solve with the session.
Okay. Um, okay. So what do you want me to do today? Should we go with the questions or activity and practice questions? Have you all tried the questions?
Yes, ma'am.
Okay. Do you have any doubts from there?
Hello,
Um,
uh,
yes.
ma'am.
Will
How
you will
the
you answer me later?
standards?
Yes, Parko, I will mail you.
Okay, afterwards.
Yes, after the session, I'll mail you.
Okay.
Yeah.
Okay.
Ma'am, how to calculate standard deviation of if standard deviation of some wrong data is given?
If standard deviation of some wrong data is given.
And mean of some wrong data is given, then how to calculate standard deviation of original data?
Or do you have the question with you? I mean, maybe it's from
Graded
assignment,
assignment, yes.
graded assignment. Graded assignment I cannot discuss because I think week three deadline is not yet over, right?
But yesterday one faculty discussed about it, not the exact question, but
In the solve with the
different
search.
values.
Okay. Let's see what question is that. Can you put the question in the chat?
Yes, ma'am. Okay.
Did you post a question? Okay. There are 6 observations in the data set. The mean and standard is copy paste this. stem and leaf
Yesterday
plot.
it is so.
Wait, I'll present my screen.
Yesterday it is solved. Mean is 20.3, and sir said he's not clear about standard deviation.
Okay.
Hello.
Yes, I'm present.
Ma'am, I sent a photo in chat box. Did I approach the correct approach?
Is this properly visible or should I just increase the font?
Ma'am, it's visible.
Mhm. There are 6 observations in a data set. Alright, so let's say my observations are x1, x2, x3, x4, x5, x6. Okay. Their mean and standard deviation are 20 and 16 respectively. So let's say for this data set, so this is my data set. The mean of the data set, let's write the mean as mu. Mean is given as 20 and standard deviation is given as 16. What is the standard deviation and mean of the original data if one of the observation is taken as 15 instead of 20? Okay. So let's say it is just saying that one of the data, I mean, let's say either x1 or x2 or x3 or x4 or x5 or x6, one out of these 6 observation, one of them is wrongly noted. So let us say my x1 was wrongly noted. Okay. So x1 is taken as, it should be 20. Okay. But it is wrongly taken as 15. Okay. So the mean that is calculated is the mean that is coming as 20. This mean is coming because you have taken x1 to be 15. All right. If one of the observation is taken as 15 instead of 20. So what is mean given? What is mean? So, okay, instead of mu, let's write it as x bar. I think this is what we would have seen. So x bar would be what? This is x1 plus x2 plus up to x6 divided by 6, right? And this is given as 20. Now, just put x1 to be 15. Okay, because this is what you had taken. So this would be just. So, okay, when you take x1 to be 15, what will you get x1 to x2 to x6 sum? This is just going to be 180 minus 15, right? If I just bring it here, right? And what is this? This is 165.
20.
Ma'am, it's 120.
Oh, sorry, 120. So this would be 105. Okay, but this is not the question you have seen in graded, right? I didn't check that. Wait. If we're doing the same question, then can someone confirm if it's exactly the graded assignment question?
Ma'am, values are different.
Values are different. Okay.
And this is the same question which is discussed in yesterday TA question.
Okay.
Sorry, TA session.
Okay. Okay. Fine. Fine. All right. So this is what you get x2 to x6 as, right? So now when you have to find the new mean, so x bar new, right? So again, this is going to be what? This is x1 plus sum over xi, I varying from 2 to 6, right? Divided by 6. We already have found x sum of x2 to x6, which is 105. So this can be just written as x1 plus 105 divided by 6. Now, what was x1? It should be 20, right?
Yes, ma'am.
So just substitute 20 over there. So what will you get? 125 divided by 6, right? So you will get x bar new equal 125 divided by 6. Is this fine?
Yes, ma'am.
Now let's move to the standard deviation. Okay. So what was standard deviation given as? Standard deviation was given as 16. All right. So standard deviation is 16. And we want to know what is the standard deviation. Okay, what is the new standard deviation? I mean, when one of the data set was taken as 15, I mean, when one of the data set was actually 20, but written as 15, then what change or what is the new standard deviation that you're going to get? This is what we have to find out. So for standard deviation, what do you know? So what we will do is we will go with the sample instead of first doing standard deviation, we'll look at variance. Okay. So what is the variance? So you are denoting it as S square, right? S square. So sample variance is sum over xi minus x bar whole square, I varying from 1 to n divided by n minus 1, right? This is what the sample variance is. Now we can do maybe this. So just solve this. So one way to do this would be
Can you check my answer?
can I check your answer? You have done it. Hold on.
Pasted it in
Give me a minute. What you have done is under root of xi is equal to 16, right? X1 square, x2 square. This you have taken the square, okay. Now variance equal expected value of x square minus expected value of x square.
Ma'am, this looks too complicated. Can we divide this formula into individual terms?
Yeah. Who send this photo? Shailaja, right?
Yes, ma'am.
In the last, what you have done in the last?
I think I taken addition instead of subtraction. I think it's wrong in variance formula.
No, I don't know. Where are you going from? Where? Okay, let me just check. Let me just check. I will solve it and just see if your answer is correct. Okay. So was the answer given to you in the yesterday session?
Sir didn't told any answer. I will. He said I will tell in another session.
Okay, fine. Let's see. So here you have 6 data set. I mean, 6 observation, right? So what you should get? You should get this as x1 minus x bar whole square plus x2 minus x bar whole square, so on to x6 minus x bar whole square, right? So square divided by n minus 1, which is 5. And I think the sample or population is not given, so I'll just go ahead with maybe population. Okay, so this should be 16 chi square. 16 chi square is 256. And what was x bar? X bar was given as 20. So you will have to take the square of everything. You will get x1 square plus x bar square minus 2 xi x bar, right? You will add it all the term. So you will go to x6 square plus x bar square minus 2x6 x bar. Okay. Divide equal to 256 times 6. Fine. So this is what this you're going to get as xi square. I varying from 1 to 6 minus 2x bar sum over xi's I varying from 1 to 6, right? Plus 6 times x bar square. This is what you should get. is 6 times 6. Now, this x bar was given as 20 to you, right? So x bar was given as 20. Okay, then again you will have to like substitute. You'll have to get the square of everything. Okay. Fine. This will go a little complicated. What we can do is we can make a general formula and then just substitute. This is a lot of values. Oh, okay. Now what we can take a slightly different approach here. So your sample variance, not sample, it's population variance. This is sum over xi minus x bar whole square, I varying from 1 to 6. Or just take it as general n divided by n. Okay. So this is going to be what? This will be xi square minus 2xi x bar plus x bar square, right? Divided by n. Now we can split this and you will get sum over xi square minus 2x bar sum over xi plus n times x bar square. This is from I1 to n, okay? Nx bar divided by n. So you can write this as, sigma square equal. Now, what can you write this sum over xi as? You can write, see, x bar is nothing but sum over xi divided by n, right? So we can write this sum over xi as n times x bar, right? We can write this as n times x bar.
Yes, ma'am.
So this
Yes,
would
ma'am.
be sum over xi square, I varying from 1 to n minus 2x bar. You can write this as nx bar plus nx bar whole square divided by n. And this will be, so you have minus 2n x bar square. So this will be just sum over xi square minus n x bar square divided by n. Fine. So this x bar is going to be same, but this is where we have to take care, because one of my data set, I mean one of my data observation is wrongly noted. So now what we can do is so you will have x1 square plus x2 square plus up to x6 square minus of n is 6. X bar was 20. So 20 square 400, 2400 divided by n. equal to 256. So 256 times 6. How much it is? Yeah. So let's say again x2 was wrongly noted. So I'll just find what x2 square to up to x6 square is. So this would be calculate 256 times 6. This is 1536 plus 2400 would be so sum of all this xi square is coming as 3936. So and this xi was 20 earlier, right? Or not 15. One of the observation is taken as 15. Yeah, it is taken as 15. So 15 square plus sum over xi square, I varying from 2 to 6 is 3936. So sum of xi square is going to be what? I varying from 2 to 6. This is 3936 minus 2 to 5. So 3936 minus 2 to 5 is 3711. Okay. This is from 2 to 6. Now for the new data set, I mean now the data set is noted as, okay, 20, x2, x3, x4, x5, x6. And for this data set, we had found the mean to be how much? 125 divided by 6. X bar new is 125 divided by 6. So the sample variance, not sample variance, I mean the variance is going to be sum over xi square minus n x bar square. So n was 6 into, you have to square it, divided by n. Okay. So this is how much? This is 20 square plus 3711 minus 6 times 125 by 6 whole square divided by 6. If you look at 100 plus 3711 minus 6 times divided by 6. We're getting 251.13. So you have to take the under root of this 5. It's coming as 15.84 prox. the new standard deviation. Okay, ma'am. I see something in the chart too. It's the same thing. Okay. Can someone cross-check the answer that was given?
Yeah, ma'am. I also got the same answer, but I have approached little differently.
It's okay. I mean, there can be different ways to answer a question. Is this clear?
Yes, ma'am. Okay.
Okay. Someone had asked stem and leaf plot. Can you tell me what doubt do you have in stem and leaf plot? Someone had asked the question. I don't know who. Damien, are you there?
Ma'am, is that the notation for stem and leaf is always the same? Like
Uh,
only unit digit will be the leaf and rest of the sum is the stem.
yes. So, I mean, in the stem and leaf plot, like, uh, I mean, you separate it into two parts. One should be stem, other should be a leaf. And in the stem, you keep everything, but not the rightmost is it, right? So whatever number do you have, like let's say you have, if I'm talking about a two-digit number, okay? Let's say I have 1112 2123 so on. So the right, look at the rightmost is it. So this one, this two, one, all this will go in the leaf. Okay. So you make a stem, a leaf, and then you write it as 1 2, right? So 1, then 2, then with 2 what a leaf you have, 1 as leaf, you have 3 as leaf, and if we keep on adding the data, your stem will also grow, your leaf will also be more, right? And let's say if you had a three digit number, then in that case let's say here it's given as 501. Okay. So let's say you have something like this 501. So this 50 will go into your stem and this 1 will go into your leaf.
Okay.
Okay.
Ma'am, if a four-digit number is given,
Again, the rightmost digit will go into the leaf and the rest will go into your stem. So in your data, you will have to see, how does the data look like, and accordingly you will decide how should like how do you want to define the stems there. But in leaf, there will always be the rightmost digit. And it is in the leaves are always arranged in ascending order, right? So let's say we had the number 11, 17, and 19. So we have to put the leaves in ascending order. So 1, 7, 9. You see here again you have 5, 9. And if observation is repeating, let's say I have 2, 11. I have 1, 1, 1, 1, 1, 1, 3 times, and then 1, 7. So you should write in the leaf 3 times 1. You cannot skip it, right? You cannot say that, okay, I have already done one as an observation, I skip other. It's not like that. You have to write each of the observation in the plot. So if 11 is coming 3 times, you have to write here 1, 1, 1, and then 7, 9. Okay.
Okay.
Ma'am, how to find the quartiles for group data?
How to find the quartiles. Okay. Okay. Do you know how to find the percentile?
Yeah.
Okay. Um, so, okay, how to find the quartile? So, you want to find, uh, like which quartile you are interested in?
Ma'am,
First or second?
it's fine with this method, but what about the group data?
What about the group data? So, you mean if you have something like this here,
Mm, yeah.
this here?
Yes, ma'am. Like data plus frequency, both are
Data
given.
plus frequency, yeah. Um, okay. Um, so let's say so the first thing that we do is you arrange the data in ascending order and then you find NP. So if you have data set that looks like XI and it's FI. So from there you will know what is your N, right? Total number of observations.
Yes.
Yeah.
So you will know your n. I mean, for example, let's say I have, let's say 1, 2, 3, 4. Let's say I'm just taking 4 numbers. And 1 is coming, let's say 9 times, 2 is coming 10 times, 5 times, and this is coming 6 times. Okay. So in this case, what is your n? This is 20. And then the first thing that you do is you do NP, right? So for example, let's say I'm interested in finding the 25th percentile. So my P is, so for 25th percentile, my P is 0.25. So NP would be 20 times 0.25. Right? This is 5. Now, you need to check whether NP is an integer or not, right? So NP is an integer in this case. So what do? At the 5th place, right? This is what you do, right? If NP belongs to Z, you take the average of values of NP and NP plus 1. So at 5th position, and before you do this, you always arrange your data in ascending order. So when you arrange your data, you will have at the 5th and 6th place, you will always be getting 1 only,
1.
right? So
Yes.
in this case, it is just going to be 1.
Ma'am, here n is equal to 30, right?
N is 30, is it?
19
Oh,
plus
sorry.
11.
Yeah, 30. Sorry. Yeah, N is 30. So you have what? 30 times 0.25, right?
Yeah.
25, 4 and 30 by 4. Okay. So 30 by 4 will be how much? 4, 7 point something, 7.25. Yes.
8th position.
Yeah. So 8th position. So 8th position, you are going to get 1. So 25th percentile is 1 here. Similarly, you can find 50th percentile, you can find 75th percentile. Right?
Yeah.
Is this okay?
Yes, ma'am.
Okay.
Ma'am, what if it is continuous?
What if it is
The same.
continuous? So in continuous, I mean, you don't know. I mean, when you write any, let's see here. So
Yes,
when you write
we don't.
data like this, you don't know what the actual value is, right? You just know that in this interval, let's say in this interval 10 to 20, you have some data coming. You don't know whether it is 10.111 or it's 15.23 and so on. You don't know the actual values. So that is why while calculating the mean, we take the midpoint, and then from there we get an approximate value of the mean. It is not the exact mean, just approximate value of mean. So even when you have data coming in this like interval, you won't know what all values are there. I mean, the actual values are there. So in that case, given a interval, it is difficult to find out the quartiles.
Okay. But here, this for this 20, it will be open bracket because 20 doesn't belong to the first class
Uh-huh.
interval.
Yeah. I'll just, yeah. It should be like this.
Okay. what about percentiles for the same?
Percentile would also be similar, right?
Not different. Uh,
So I mean, percentile will also be similar, no?
okay.
I mean, whatever we discussed for quartile.
Okay then. Thanks, man.
Any other doubt?
Yes, ma'am. In Pareto chart, what we have considered the variables should be in ascending orders. Is it? Is it
Ascend-
always?
no. I mean, it can be both. I mean, you can arrange it in either ascending order or descending order. It just the order should be maintained.
Yeah. Okay, but I'm talking about the variable. Right? जैसे x
Variables.
x एक्सिस पर जैसे हमने एक कैटेगरिकल वेरिएबल लिया
ठीक है.
लाइक ईयर
Okay.
जैसे जैसे 1994 1996
Okay. Mm-hmm.
सो हम उसको ऑलवेज टाइम सीरीज में ही रखेंगे या फिर वी कैन अल्टर द ऑन ईच अदर ऑन अनदर
नहीं
इज
उस
इट नेसेसरी
टाइम सीरीज में ही रखना है क्योंकि एक ऑर्डर है ना वहाँ पे ईयर का. ये बेटर
बट
होगा.
बट फॉर पेरेटो चार्ट और द फर्स्ट प्रायोरिटी शुड बी द फ्रीक्वेंसी गेट असेंडिंग एंड डिसेंडिंग ऑर्डर में रखते हैं ये हमारी फर्स्ट फर्स्ट प्रायोरिटी रहती है या फिर हमें वेरिएबल्स को जो है एक ऑर्डर में रखना होता है ये फर्स्ट प्रायोरिटी है
कि अगर हम कुछ भी आई मीन देख रहे हैं कि ईयर वाइज क्या परफॉर्मेंस रहा है या तो इट्स बेटर टू लाइक see it year wise, no? I mean, let's say in 2020, like 2000, 2001, so on, you ऐसे जा रहे हैं हम, ठीक है? और मे बी 2005 पे गए, 2010 पे गए, और 15 पे गए, 2020 पे गए. मान लो कि हम चेक कर रहे हैं कि हर साल मीन्स एट 5 years इंटरवल क्या प्रोडक्शन का रेट रहा है. So it's better to say it like this, right? In the like
यस यस
in the
ओके
series. अगर हम
ओके
ये
अगर
if we try to
यस
अगर कोशिश कर रहे हैं कि हम प्रोडक्शन के हिसाब से जाएंगे then it's difficult to also view कि कौन से ईयर में ज्यादा है. ये थोड़ा
यस मैम
सही. It's not good.
yes ma'am consider a case year 2000 the production mm, let's say 5 unit and 2005 takes 4 unit and 2010 take 10 unit
Hmm.
and another then the production say something like 3 and next one would be 20 या 10 या 1 सो इस केस में हम क्या कर सकते हैं अगर इसको हमें पेरेटो चार्ट में रखना है तो सो हियर वी कंसीडर द फ्रीक्वेंसी लाइक नंबर ऑफ आइटम्स प्रोड्यूस्ड
नहीं
इन
अगर
असेंडिंग एंड डिसेंडिंग
सी अगर डेटा ऑर्डिनल है so you should always maintain the order, right?
ओके लेकिन फिर ये तो पेरेटो चार्ट नहीं हुआ ना फिर
नहीं ये पेरेटो चार्ट नहीं हुआ फिर.
यस सो अगर अगर हमें कंपलसरी कहा जाए किसका पेरेटो चार्ट कैसे बनेगा तो हमें तब फिर ऑर्डर फिर तो हमको सेकंड प्रायोरिटी रखनी पड़ेगी
हाँ उस केस में यू हैव टू हाँ सेकंड प्रायोरिटी रखनी पड़ेगी.
Okay.
But like if your data is ordinal, you should maintain the order.
यस सर, तो यस मैम। सो तो फिर हमें वही ना, मतलब अगर अगर दोनों बातें सही होती हैं तो फिर हम वो जो है वो केस सही मानेंगे। अदरवाइज हमको प्रायोरिटी ये रखनी पड़ेगी ना कि हमको फ्रिक्वेंसी वाइज रखना है, लाइक असेंडिंग और डिसेंडिंग ऑर्डर। हमारा बार
I
ग्राफ
think
किस
it
तरीके
is
से
more
असेंड या
like
डिसेंड।
कि क्वेश्चन क्या डिमांड कर रहा है, and क्या रिक्वायरमेंट
यस
है,
यस मैम,
on
अगर
that
अगर
basis.
उसमें आ जाए कि नो सुटेबल पेरेटो चार्ट, तो हम उसको करेक्ट करेंगे। अदरवाइज अगर हमें चार ऑप्शन ही दिया कि नहीं हमको इसी में से चूज करना ही करना है, तो फिर हम इसमें से कोई ना कोई एक ले लेंगे, आइदर असेंडिंग और डिसेंडिंग।
हम्म
है ना, लाइक जो है हमको चार ऑप्शन दिया है, एक में असेंडिंग ऑर्डर फ्रीक्वेंसी दिया है, दूसरे में डिसेंडिंग ऑर्डर फ्रीक्वेंसी दिया है,
हम्म
एंड तीसरा टाइम सीरीज, मतलब इसका ऑर्डर फिक्स कर रखा है
हम्म
कि 2000 से लेकर 2020 तक इन सीक्वेंस। एंड फोर्थ ऑप्शन दिया है कि none of the above is suitable,
हम्म
then which option would be correct?
And the question is, which among the following is the correct representation
Correct
of the
Pareto
Pareto
chart
chart?
for the given. Yes.
Then option 1 and 2 should be correct.
यस मैम, लेकिन वहां पे तो हमारा ये ऑर्डिनल ऑर्डिनल कैटेगरी तो यहाँ पे फिर वो हो गई ना, अल्टर हो गई हमारा। जैसे हम इसको अगर असेंडिंग करेंगे तो सबसे
See,
पहले
yeah,
रखेंगे 2020,
हाँ.
देन
I think,
2005।
when we say order, order, like order of what? This is also that we should take care of. I mean, is year in itself a order? I mean, it's again a very subjective question. Um,
यस सर, लाइक it is categorical variable in fact, year.
uh,
So
I think it all depends on what the question asks, what is provided in the question, or what are you interested in looking at.
यस मैम, एक्चुअली ये ग्रेडेड असाइनमेंट का क्वेश्चन है, मतलब उसमें ऐसे ही था, तो उसमें हमें कंपल किया गया था कि नहीं आपको चूज करना ही है।
Uh,
मतलब चार ही ऑप्शन दिए थे, उसमें से कोई भी ऐसा मतलब क्लियर नहीं, तो इसको फिर
Let me check. On this is week 1, is it?
नो, वीक वन नहीं मैम, ये वीकली मॉक आया है ना, इसमें इसमें शायद से था।
Okay.
लेट मी चेक। यस, वीकली मॉक का लास्ट क्वेश्चन है, बट इट इज ग्रेडेड, सो हमने मतलब सेम टू सेम डेटा नहीं पूछा। मैम ये लेक्चर्स में मैम ने कहा था कि हम पैरेटो में सबसे पहले यही देखते हैं कि आइदर द फ्रीक्वेंसी इन असेंडिंग ऑर्डर और डिसेंडिंग।
Hmm.
फिर लास्ट में लेक्चर क्लोज करते करते मैम ने कहा था कि ये अगर जो है हमें नीचे ऑर्डिनल डेटा दिया हुआ है, तो हम बेटर उसको प्रेफर करें कि ऑर्डर में ही रखें।
Right.
इफ बोथ द केसेस अराइवल, देन
Hmm.
इस वजह से थोड़ा सा कंफ्यूजन थी।
Ma'am, that means if we take a bar chart of ordinal data and the categories are not ordered, that is invalid bar chart.
नो,
No, it's not invalid bar chart. It just says you should maintain the order.
यस,
Mm.
नॉट इनवैलिड,
But
बट
there
if
was,
if the data is ordinal, then we have to take as
yeah,
much possible in the order.
that's when I was specifically it said that it is ordinal data.
यस, अगर मतलब जहां तक पॉसिबल है हमको उसको ऑर्डर में ही रखना पड़ेगा। अगर मतलब पेरेटो चार्ट की पहली डिमांड यही है कि हमको उसको फ्रीक्वेंसी के
Frequency
ऑर्डर में रखना
order.
होता है। यस, उसकी पहली डिमांड ये है। तो अगर दूसरी डिमांड भी फॉलो हो जाती है तो फिर क्या दिक्कत है?
Pareto chart में categories भी order हो सकते हैं।
वही तो क्वेश्चन है ना।
Pareto charts are also bar charts, right? So
यस,
yeah,
हम बार चार्ट से ही पेरेटो चार्ट कंक्लूड करते हैं ऑलवेज।
Any other doubts from week 3?
Oh, can anyone explain me box plot chart?
Box plot. Okay.
hello ma'am.
Hmm.
When do we prefer horizontal graph or vertical graph?
Uh, Horizontal graph or a vertical graph?
Ordinal. I didn't get your point. Can you please rephrase it?
No. What did you say? I mean, horizontal graph or the vertical graph?
Yeah. Like when do we prefer horizontal graph?
I don't
Horizontal,
think
like
there
I mean,
is.
horizontal graph mean I mean to say horizontal bar chart.
I don't think there is any such preference. It depends on you. I mean, if you want to show something using a horizontal bar chart, it's your choice. There is no preference to say.
There was a question in activity question where bar charts and Pareto charts again. It was asked to choose the correct option. There was a bar chart which is horizontal, but all data points are correct, and the categories are not ordered.
या
Yeah.
Which question it
So,
is?
but it's not necessary for them to be ordered. I think so based on.
Which question it is?
Mm,
I
I
mean,
have
can
to
you
check.
tell me what activity, practice, which one?
Um,
So I can check once.
maybe 2 around 2.4 to 8. I have to check. I don't remember.
Okay, can you please check and let me know?
Okay.
Somebody asked the box plot.
Yes, ma'am. It's me.
Uh,
It was in activity question from statistics week 3.
Activity question.
Wait, yes. Wait, I am trying to access it.
Okay.
It's difficult to open it in phone.
No, sorry, can you repeat?
I am trying to open it. I will tell you the question number. 1 minute.
Okay.
Oh, do you have a notepad?
Yes.
Okay, 1 minute. Okay, ma'am. Activity 3.5, question number 7. Actually, there are three questions related to this box plot chart.
Okay. AQ 3.5, question number 7. 5. Question number 7.
Wait, below question number 7, 8, 9, 10,
Below?
10. Shall I share my screen?
No, I will tell you. So,
And question number 8, 8 to 10.
8,
I
9,
got
10.
it.
Related.
I got it. Yeah. So you have a box plot
Yes,
and it starts at between 15 to 20 and then at 50 to 55. Okay.
52 blocks. It start from 18 to 52.
Something like this. Now, the question is, what is the approximate first quartile value?
Ma'am, can you teach me how to read this box plot first? How can I get values from it?
Okay. So what is the first, the lower line that you see, the lower value here.
Okay, 18 or 17, perhaps.
You got this, right? This line.
Yes,
So
18 or
maybe,
17, perhaps.
yeah. So maybe somewhere there, right? So somewhere in the neighborhood of 15 to 20 you have, right? This is
Okay,
this line is your Q1. Okay. And this
okay.
line is your Q3.
Ma'am, why this line is Q1?
This
Because,
is this is how box plot is made.
okay,
This is how it is made. So from here, you need to find what is the first quartile, what is the third quartile, or what is the interquartile range, and what is the range of the data. So for first quartile,
okay.
you see it should be somewhere between 15 to 20. So Q1,
You
look
can
at the
take
question.
7,
So look
8.
at the question. In the option, it is given as 25, 52, 19, 68. So out of these four, 19 looks reasonable. So let's say I'm taking Q1 as 19. Now what about Q3? So Q3,
Yes,
again, it should be somewhere between 15, what it is? 50 to 55, right?
50 to 55.
Right? So 50 to 55, maybe
Okay,
I can, let's say, take it as 52. Okay.
okay,
Then what should be the interquartile range?
okay.
This is 52 minus 19. And this is what? 12 minus 9 is 3 and 3. So interquartile range should be somewhere close to 33.
But ma'am, answer is like 66, perhaps.
No, it is 33.
Okay, okay. Range of data. Yes,
Yeah.
interquartile 33. Yes.
Now you have to find the range of the data,
Okay.
right? So range
Yes.
of the data is what? Max minus min.
Okay. Yes.
Now, the whiskers star I draw is not same. So if you look at the whiskers, it goes max somewhere between 65 to 70. So let's make it 65 to 70. And the lower one goes to
0 to 5.
0 to 5. So this is 0 to 5. Okay, let's say this is 5. So the max, let's say I can take, maybe I can take max to be 67 and min to be maybe 3 I can take. So it should, the range should be somewhere in the neighborhood of 64. And if I look at
Yes,
the options, it is, I mean,
it's
any value that I put between 64 to 66, it's taking as correct. So it's fine.
okay.
Yeah.
Thank you. Ma'am, what are the whispers? You said
This,
that line.
this line. Yeah. This is called.
Yes, but what does this represent?
I mean, see, if you have a data set, right? I mean, you have some values, but it's not like all the data are going to be in this range, right? This is just interquartile range. So it's not that all the data are going to fall in this. There will be some data which are going to be, which is not in Q3, which is not in this plot box reason, right?
Okay,
So those are coming on these whiskers, these lines. Okay.
okay, I get it now.
But what the
Thank you, ma'am.
actual, yeah. All right. Any other questions? Anybody else have any question from week 3?
Ma'am, I pasted one question in chat.
Yeah, post it. I don't see any question. Okay, yeah, there is one. The question is the mean of 20 values in a given data set is 50. When these values are rearranged in a certain order, the mean of the first 10 values and the last 11 values are 40 and 60. Find the 10th value after the rearrangement. Okay. So you have 20 values, right? So x1, x2 to x20. So mean is, let's say mu. This is sum over xi, I varying from 1 to 20 divided by 20 is 50. Okay. Now, what the question says is, if you arrange these values in a certain order, so let's say my first 10 values, x1 to x10, and in x11, x12 to x20. So what it is saying is the mean of the first 10 values are 40. So sum over these xi's, I varying to 1 to 10 divided by 10 is 40. And the last 11 values, so the last 11 would be these, right? So sum over xi from I varying from 10 to 20 divided by 11 is 16. So you need to find this 10th value after the rearrangement. So this is after the rearrangement, right? So you need to find what this extent going to be. Fine. So
The difference between
difference between,
individual sums will be the
yeah,
10th
so
one.
uh so from here, I mean, what is, you can just take it this one. So x10 plus sum over xi okay, this mean was also given. The overall mean is 50. And this is what? This is sum over xi, I varying from 1 to 9. Still 400. Now you put it here, so we will get what? Sum over xi from 1 to 9 plus x10 sum over xi from 11 to 20 is equal to what? 1000, right? So this, you know, is 660. So sum over, no, sorry, you have to find x10 now. What you can do is, let us substitute.
Yeah, we have
Oh, your voice is breaking. Can you repeat? This is wrong.
660.
Oh, this is 660. Okay, fine. Yeah. Yeah, now it's fine. So this is 1060 minus 1000 equal to x10, right? So x10 is 60. Is this fine?
Ma'am, can you please explain once again?
Okay. See, you had 20 observations and their mean was given to be 50. So this is what we mean. We mean that sum over xi varying from 1 to 20 divided by 20 should be 50. Okay. This is what it is mean. Now, what the question says, let's say in among the data set, among all the observations, we have done some rearrangement. So let's say we arrange it in some certain way. And what we're saying is after this arrangement, the mean of the first 10 values are 40, is 40. And the mean of the last 11 values is 60. Okay. So this is what we have written. Sum over xi, I varying from 1 to 10 divided by 10 is 40. And sum over xi, I varying from now 10 to 20 because we're talking about 11 observations. So even 10 would count divided by 11 equal to 60. So solving the first one, you get sum over xi, I varying from 1 to 9 plus x10 equal 400. And solving the second equation, you get x10 plus sum over xi, I varying from 11 to 20 equals 660. Fine. Now I can substitute these values over here. Okay. So sum over xi is what? This is x1 plus x2 plus up to x20. So this is sum over xi, I varying from 1 to 9. Okay. Then x10 and then sum over xi, I varying from 11 to 20. Fine. So sum over xi, I varying from 1 to 9. This you can write it as from here 400 minus x10. Right?
Yes, ma'am.
Okay, what we have done is, okay, sum over xi, I varying from 1 to 9 plus x10, we have written as 400. So these two combined is 400, right? And this sum over xi, I varying from 11 to 20. So this is 660 minus x10, right? From here, 660 minus x10. So this is what we have written, 660 minus x10. Fine. This is fine.
Yes, ma'am.
And all this, I mean, sum of all this was 1000. So from there, you just solve it and you get x10 to be 60. Right?
Yes, ma'am.
Okay. Any other doubt?
Ma'am, I have a doubt. Hello.
So, yes.
Can you explain how to find maximum outlier and minimum outlier?
Maximum outlier and minimum outlier. I mean, if you're looking
Ma'am,
at the
I too have a similar kind of doubt. What is the difference between minimum, maximum, and outliers?
what is the difference between minimum, max, and outlier?
Yeah.
No,
Oh,
see,
there's yeah.
when you are talking about a minimum value, I mean, in your data set, whatever is the minimum, that is minimum. And whatever is the maximum, that is the maximum.
Okay.
Right? But outlier is something that we see, I mean, that we didn't expect in the data set to be, right? Like, for example, let's say you have the data set where the values are 1, 2, 3, 4, 5, and the sixth value, let's say, is 15. right? Which, like, if you are taking any observation and let's say most of the data set that you saw is 1, 2, 3, 4, 5, and one value you saw it to be 50, it's not expected, right? I mean, something is going wrong. I mean, this is an outlier in the data set. But still, if you're saying that I'm interested in, I mean, I want to know what is the maximum value, it's still 50 itself, right?
Yeah.
I mean, we had a formula for this. Uh, I
Finding the
saw,
outliers.
yeah, minimum and maximum outlier. I
Uh,
don't see in the lectures. I don't know why.
it's in the tutorial, I think. So, I mean,
Yes.
the formula says that your outliers should be less than Q1 minus 1.5 times interquartile range. And this should be, or maybe I can write it as, so your outliers, the upper, okay, fine. Okay. Q1 minus 1.5 times interquartile range, and it should also be greater than Q3 plus 1.5 times interquartile range. So anything, let's say, if let's say this is Q3 plus 1.5 times IQR and Q1 minus 1.5 times IQR. So anything beyond this or anything below this, whatever you get, we are calling it as outliers, right?
Why we are multiplying with 1.5?
Why that I don't know. Why we are multiplying by 1.5, that I'm not really sure about.
Ma'am, can you derive this because uh, except this I have derived all from.
Yeah,
I
ma'am.
can't by heart it.
If you could derive, it will be very
Yeah.
helpful for
I
us.
don't
It
know
will
how
be.
to derive this actually. I mean, because outliers is something that you're getting from the data set, and this what I think is this has been found using some measurements that have been taken, and maybe or right now I don't know how to derive this also. I don't think
Seeing
there is any
binomials
derivation.
or any kind.
No, I don't right now. I don't know. Like if there is any derivation, I'm not really sure about. Um, and how it has been obtained. This formula, I'm not sure.
Is it in the book you have referred?
Is it in the book?
I'm asking you, ma'am, since you are
No,
instructor.
I have not seen the derivations before. For this at least.
Okay. And please.
If there is derivation, we'll ask to upload it on board or it on portal itself.
I guess the derivation is of very high, statistics, advanced statistics will give the derivation.
Uh,
Yeah, because like there is a statistician called Tukey who gave this method. I don't know.
okay.
And ma'am, how is sample variance found? How is that derived?
How is sample variance derived?
Yeah.
That is a
that n
definition, no?
minus 1.
N minus 1, see, why it is N minus 1 and why not N? You will learn it only in statistics 2 course. So there is something called unbiasedness, biasness. So those concepts, if I tell you now, it will be difficult, no? You'll have to understand the
Okay.
whole theory. So, but this is how it is obtained only because the sample variance, this division by N minus 1, it gives you an unbiased estimator. This is all I can tell you right now. But again, you'll have to go to stats to learn all those terminologies.
That
Yeah,
means in week 5 or 6.
not week 5. It will come only in week 9 for week 9 of stats 2.
Oh,
When you study the
so,
inferential statistics.
Ma'am, while calculating percentile, if
Why
the
cal?
hello,
Yes, yes, tell me.
while calculating percentile, if I have NP as an integer,
Hmm.
so I'll have to take average, right?
Correct.
So the value that average produces
Hmm.
is the percentile or the or like
No, no, no. That I mean that value, the data set at that position is the percentile.
I mean if the average value is 2.5, so
The third,
2.5.
you look at the next one, right? I mean the third.
Okay, so we'll take the smallest value greater than that
Hmm.
average,
Yes,
and that observation will be the that percentile.
yes.
Okay.
ma'am, when will inferential statistics start?
It will start from
From which way?
week 7 of stats 2.
Oh, okay. Ma'am, I have another doubt. What is rank of percentile?
Rank of percentile.
Yeah,
Has this been taught? Uh, no, right?
yeah, ma'am. It was in a lecture. Like a Google Sheets use different kind of algorithm
Function.
for finding percentiles in that. Seeing rank and percentile form.
This function is used in Google Sheet, is it?
Yeah.
What does rank function does?
I have noted the um, um,
Calculating percentile from Google Sheet, that I've not explored. So rank,
or it's like range is equal to percentile into n minus 1 plus 1. I don't understand this thing.
and what is the output that you're getting using this rank function? I mean, what does it find?
Percentile.
Percentile it finds.
It's the same we find using NP method.
Okay.
The same is being
So maybe this
found.
function has been used to find the percentile in Google Sheet.
Yes, ma'am. It is especially used in the Google Sheet for finding percentiles.
Using this function, it's directly finding the observation, like not the way we find the um, nth observation. It
Yes.
will directly find the value of the observation.
Yeah. So maybe this function, so this function in Google Sheet is giving you the that particular percentile value.
Yeah.
Anything else?
Practice assignment, I have a doubt.
Okay. Tell me. Which question?
It says to find sum of a plus b.
Practice assignment 3.1 or 3.2?
3.1 question number 4, if that's the same question.
No, I don't think so. What is the question? The question is to find the value of a plus b.
Yeah, at the
A
end it says
plus
a plus b.
b.
Sum of a plus b.
See that question. Okay, yeah, I got it. The solution is given to you, no? So in this question, you have again the mean and standard deviation given to you, and the mean and standard deviation for the other set of observations are also given to you. And what you have to find is what is this A and what is this B sum. Um, okay, if you can tell me what exactly you didn't understand there, maybe I can help.
At first I tried solving this question, but I was stuck in the initial step. Couldn't move one step also.
Okay, wait.
I don't know how to approach this question.
So the question is that you have x1, x2. It goes on till xn, is it?
Yeah,
Okay, and what is the mean given?
mean for this is 20,
And what is the standard deviation?
5.
And then you have 3 times, no, a times 3x1 plus b, x1 plus b, so on. A times 3xn plus b. This is given. And what is the mean for this?
Mean for this is 94.5
Okay. What is the standard deviation?
and standard deviation is 22.5.
And you have to find what is the value of A plus B. You need to find first, you need to find what is A and what is B for this, right? Okay. See, if you have to find the mean for the second second set of observations, what will you do? You will do A times 3x1 plus B plus up to A times 3x n plus B divided by n equal 94.5. Right? And this is same as A times this is 3A x1 plus AB, so on 3A xn plus AB equal to 94.5 times n. Okay. Now, see, I can just split this. So AB is coming n times. So it will be n times AB plus 3A sum over xi, I varying from 1 to n. 94.5 times n. Right? Now you can take this sum of xi's from the first one. Right? So what will you get? You will get sum of xi to be 20n. So n times AB plus 3A times 20n equal 94.5n, right? So from here you can find AB, A times B, and that would be something. I mean, you will get something here. So n will get cancelled out anyway. So AB plus 60A equal 94.5. This is one equation you got. Now you can use the standard deviation and you can get some relationship between the standard deviation of the first and second set of observations.
So up to now we have done with the help of mean, and now we'll do with standard deviation.
Yeah, and okay, I think here
From a standard
Ma'am, I
deviation,
have solved this question.
we can get the value of A.
Okay, so standard deviation of these x's is 6, right? So now this, can you mute yourself? Yeah. See, what we can do is we can also use the properties of this mean and standard deviation. So initially you had the data set x1, x2 up to xn, right? And this their standard deviation is given as 6. Now you can do, I mean, if you multiply, so you are multiplying it, right? You are multiplying 3 to xi. So if you do 3 of xi, what is the standard deviation going to be? 3 times it?
15. 15.
15?
Yeah, standard deviation given as 5.
Oh, it is given as 5. Okay, fine. So it is 15, right? Now you multiply A into this. So if you multiply A, so 3A xi, this will be 15A. And if you add something to this, 3xi plus B, it will still remain as 15A.
Yes.
Yeah.
Addition a constant doesn't make any difference.
Yeah. So it still stays 15A. So the standard deviation for the second set of data set, second set of observations is just 15A. And this 15A is given as 22.5, right? So A would be
1.5.
22.5 divided by 15, which is 1.5, right? So A we got. And maybe you can just substitute over here. I think even for expectation, we could have used the property, I guess, simpler. So A is 1.5 times B. So 60.
Which property you're talking about?
I mean, if you have xi, a set of mean is 20. If you add multiply it by 3a, you will get 3a times 20. And if you add b also to this, mean would be 3a times 20 plus b. So this 60a plus b should have been this 94.5, right? A we got it as 1.5. So 60 times 1.5 is what? 15,690.
And A times B we over, because there
So
is a small
it's
bracket.
no. What is 60? What?
The second set of data we are given A times whole multiplied by 3x1
Okay.
plus B.
Yeah, right. Here it should be AB also, right? Yeah, correct. I mean, we got the same thing actually. Yeah, AB plus 60 times A. So 1.5B plus 60A, which is 90, equal 94.5. So 1.5B equal 4.5 and B equal 3. So you got B to be 3, A to be 1.5. So A plus B is just 4.5.
I understood how this equation came, but the standard deviation one was, can you please? Yeah, this one.
See, if you have X, okay, if you have a variable X, and no, sorry, if you have a data set Xi, okay. So if this standard deviation is sigma, let's say. So you know the property, right? I mean, if you multiply each of these observations by some constant. So in this case, our constant was 3a. So we multiplied each of these observation by 3a. So standard deviation also gets multiplied by that constant.
Mm-hmm.
So this should be 3a sigma.
Mm-hmm.
And now if you add something, I mean, if you add some constant to this or to all the observations, it doesn't make any difference to the standard deviation. So it will still be 3a sigma,
Mm-hmm.
right? So this is what we have done here. So before, I mean, we multiplied by 3, the whole observation by 3, we got the standard deviation to be 15. Then we multiplied by a, it became 15a, and then we added by ab, right? So it didn't make any difference because you're adding a constant to each of the data point. So it doesn't make any difference to the standard deviation. So it still stays as 15a, right? And now this 15a was nothing but 22.5. This is given to you. So we
Mm-hmm.
have just substituted.
Okay, can you zoom a bit? I'll take a screenshot.
Yeah.
Yeah, done.
Ma'am,
Huh?
ma'am, may you answer my question from week 1?
Week one. No, week one. Let's not go to week one right now.
Okay, ma'am. Thank you. Okay.
We'll take one more session on Sunday for week one and two. So
Okay.
let's revise it there. Do you have any
Okay, okay.
question?
Yes, ma'am. No problem. Okay.
Okay. It's already 8 almost.
Ma'am,
You
do
have
you
any?
have
Huh?
any solution for the solution PDF for the practice assignment?
I think the practice assignment solutions are there on the portal itself. I mean, you check answers, you will get the answers, solutions.
Yeah, but at once I don't get all of them.
Means?
I mean, once I reload it, I get only 3 questions, and
Yeah, then you can reload it again. You'll get different set of questions. If it's still, I mean, you'll have to keep trying it out, trying different questions.
okay, I can do that. But ma'am, I don't get any graded assignment solutions of 1 and 2.
You will find it under the supplementary content.
I
Go to
mean,
supplementary content and check for the graded assignment solutions.
Yeah,
and
yes, ma'am. It is there.
but for me, it's asking for permission.
You
No,
should
no, no.
use your student ID.
The problem is solved.
Okay,
You
let
can
me check.
access.
All right then. Let's close the session for today.
Yeah, it's working.
Okay.
Okay.
Okay. All right. Thank you all for joining. We'll meet again on Sunday.
Thank you.
Thank you.
Okay.
Thank you.